factorization. We are actually going to do this lesson twice. We're going to work on this lesson today, and then we're going to work on it again tomorrow. Okay? So the reason why we're doing that is because if you cannot do prime factorization, then this entire chapter is going to be really tricky for you. Okay, so because we use prime factorization all throughout this whole entire chapter. And so once I get started showing you, I hope that you're going to remember doing prime factorization in 4th grade. I'm hoping, hopefully. So let's look at what our essential question is. Our essential question says, what strategies can be used to multiply whole numbers? So just like in the video that we just watched, they showed us how if you were trying to multiply 60 times 40, you could always multiply 6 times 4 first, and then add the zeros on at the end. So that's going to be one of the strategies that we talk about when we multiply by powers of 10. There's lots of different strategies as we start working through this chapter that you'll notice. And just like I told you in the first chapter, you're not going to use every strategy on every question, but it's kind of like all tools in your tool belt. So as we start working and I give you some problems, you'll say, oh, well, with this one I can do mental math because I can just multiply 6 times 4 and get 24 and then add the zeros on. That's mental math. Sometimes you're going to want to decompose the number or break it down into smaller chunks before you multiply. So it just kind of depends on the numbers. So each one of the tools that I give you for this chapter, you will not use every single time, but it'll give you the opportunity to use them if you need them or when you need them, when it's most appropriate. Here's your problem of the day. 3 numbers have a sum of 45. The greatest of the 3 numbers is 2 greater than the least number. What are the numbers? And then it says to explain how you solved for your answer. So let me read it one more time. 3 numbers have a sum of 45. So that means when you add 3 numbers together, your answer is going to be 45. Now, the greatest of the 3 numbers, so the biggest of those 3, is 2 more than the smallest. So the biggest and the smallest number are only two numbers apart from each other. So wouldn't that mean that the numbers are in order, right? So the numbers are consecutive, which means they're in order, like 5, 6, 7. Those are consecutive. So the biggest number, which is 7, is 2 bigger than the smallest number, which was 5. But when you add them together, they have to equal 45. So 5, 6, and 7 wouldn't work, right? Because those numbers are way too small. So figure out what 3 numbers do you think that would be. So maybe you want to start like this, because you're going to have 3. Actually, you could put addition signs in between, because you're going to add them up. And the sum of all those numbers is going to equal 45. So think for a couple of minutes. Think by yourself first, and then I'm going to give you some time to talk with your group. Some of your conversations. What I saw was a lot of people writing numbers in on those 3 lines and then adding it up, and when it wasn't right, if the number was too small, then they were changing their answers and making the number bigger, and then adding it again, and then making their number bigger. If their number was too big, then they were making their number smaller. So that's called guess and check. There really isn't a way to figure this problem out unless you just got lucky and picked the right 3 numbers. But it's really about guess and check. You have to pick 3, and then you have to see where that lands you. Is it too big or is it too small, or did you accidentally get it right the first time? So once you figure it out, that's when well, you have to try to figure it out first. So guess and check means you keep guessing and checking until you get the right answer. So in this case, I saw a lot of 20, 25, 20 plus 20 plus 5. That indeed equals 45, but that didn't follow the riddle here, which is that the numbers have to be consecutive. So it's 3 numbers that have to, the biggest one is only 2 bigger than the smallest one, which means they have to be consecutive. So the numbers had to be in order. So, Jameson, what answer did you get?
I got 16, 15, and 14.
So 14, 15, and 16. When you add those numbers up, those equal 45. Let me show you a quick way to add those numbers up. Each of these have 10s, right? So 10, 10, and 10 makes 30. Then this 6 and 4 make 10. So that's 40 plus 5 more equals 45. And I didn't even have to add them. I didn't have to even line them up to add them. So those three numbers equal 45. Do you guys see how we got that as our answer? They had to be consecutive. So it had to follow all of the clues here. This is the greatest number, and it's 2 more than the smallest number. So that fits the requirement. Okay, you can erase your board. Written there. And the title of today's lesson is Prime Factorization. The date would be a good thing for you to put there too. Take your notes with you, Jesse. So we have some vocabulary words to write out here first. The first one is prime. So we're going to write what prime means, the definition of the word prime. It's a number with only 2 factors. Thank you. So an example of prime numbers would be a 2, because the only thing that you can multiply together to get 2 is just 2 times 1. There's no other numbers you can multiply together to get 2. Another example of a prime number is 5, because the only things you can multiply together is 5 times 1. Prime numbers are not always small numbers. So we have big prime numbers too. So you could have numbers that are even bigger than 100 that are prime numbers. Just because they have, it means that the only 2 factors they have are 1 and itself. That makes it a prime number. Sometimes you'll notice that a lot of prime numbers happen to be odd numbers. But that doesn't mean that all odd numbers are prime, right? Because 9 is an odd number, and 9 has more than 2 factors, doesn't it? Because you can also multiply 3 times 3 and get 9. Besides just 9 times 1. Same with 15. 15 is an odd number, but you can multiply 3 times 5 as well as 15 times 1. So don't automatically think because the number's odd that it's prime, but a lot of odd numbers happen to be prime though. Okay? So this is all review. It might even be review from 3rd grade, but I know for sure from 4th grade. Your other example is composite. This is our other vocabulary word. And basically, if it's not prime, it's composite. If it's not composite, then it's prime. So a number with more than 2 factors. For example, a 4 is prime because you can do 4 times 1 and 2 times 2. The number 10 is composite because you can multiply 2 times 5 as well as 10 times 1. So anytime a number is not prime, a number is composite, except the number 1, which is has its own special kind of category because it only has 1 factor, 1 times 1, which is really just a 1. So 1 is really not considered prime or composite. It's kind of in its own category.
Odd.
Yes.
What would a 0 be?
Zeros.
It can be extremely composite, but also extremely prime. Because it has infinite factors.
You're right.
It has to be times itself.
But 0 is not. It does have infinite factors because any number times 0 gets you 0 as your answer. So any number times 0.
This would mean it's sort of prime because it only has 2 factors. 0 and something else is prime.
So 0 is not a counting number. It's not one of the numbers that we are talking about here. Yeah, right. It just starts at 1, the counting numbers. So we start 1, but 1 is one of those numbers that's a little bit different. Is really the only other one that we're talking about. So 2 vocabulary words so far for your math notes. And so we have the word prime and the word composite. One more is the word factors. So all 3 of these words we're going to be using a whole lot during this chapter. So factors are numbers that you multiply together to get an answer. Okay, so numbers that you multiply So, for example, well, actually, I'll let you copy this down, and then I have to erase this to write a big example there. So, factors are numbers that you multiply together. So, for example, 10 was one of the last numbers that I used as an example. So, 10 has 10 times 1, that counts as 2, right? 10 and a 1. And it also has 2 and 5. 2 and 5. So, 10 has 4 factors, okay? So, factors are the numbers that you multiply together to get a number. So, once we start talking about factor trees, which we're going to start talking about here in a second, I'm going to ask you to come up with 2 factors. And when I'm saying factors, I mean 2 numbers that you multiply together to get that number. Okay? So this lesson today is about factor trees. The purpose of a factor tree is to work your way down till you have only prime numbers at the bottom of the factor tree. Because we have to find prime factors. Remember, the title of our lesson is Prime Factorization. So we're finding prime numbers at the bottom. So here's our first example. We're going to use the number 30. And I'm going to do like this upside down V. Make sure this is in your notes because this is our first example. We have a few to write in there today. So this is what a factor tree starts out looking like. Nod your head if you remember doing a factor tree last year. Good, good, good. Okay. That's what I was hoping to see. So a factor tree is a way for you to organize all the numbers so that you can tell once you get to prime numbers. Okay. You can also make a list of factors, but making a factor tree ensures that you don't miss anything. So here's what I wanted to tell you about factor trees. You can start with any 2 factors of the number. It doesn't have to be the same. So 30 has lots of factors. So one person may decide they want to start with 6 times 5 as their 2 factors. Somebody else may decide they want to do 10 times 3 as their factors. Somebody else can do 15 times 2 as their factors. All of those things equal 30. The only thing you shouldn't use is 30 times 1. Because if you use 30 times 1, you're going to just have to start over again and then find factors of 30 all over again. So don't use the number times 1, okay? So I left some space here because I'm going to show you how if you use different factors, you're going to end up with the same answer. That's why I made it kind of small on the side. So let's start out with 6 times 5. So I'm going to write the 2 numbers here that I'm multiplying together to get 30. So each of those numbers go at the end of my upside down V. So those are like branches of our factor tree. Now every time we hit a prime number, we're going to circle it. Okay, and then it kind of shows us that that limb of the tree can't go any further, because like what we know about prime numbers now is that prime numbers are you can only multiply 1 and itself. So in this example, 5 is a prime number, so I'm going to circle it. If I try to continue the 5, all I can do is 5 times 1 and then over again, 5 times 1 and then over again, 5 times, like it's going to go on and on and on, right? So once you hit a prime number, you circle it, and then you can stop on that branch of the tree. Now this branch of the tree needs to continue. So how can I break down the number 6? What are 2 factors of 6? Malachias?
3 times 2.
3 times 2. So I'm going to put a 3 and a 2 here. If you put 2 times 3 instead of 3 times 2, same thing, right? Because multiplying, you can do it either way. Okay, so now we're going to look for prime numbers again. So are either of those numbers prime? Anthony? It's like an upside down V. We're continuing. I'm taking this number 6 and I'm breaking it down into these 2 numbers, and that's what the upside down. It's a factor tree. Just draw it. What you're doing is you're breaking down the 6 into 2, and so it has 2 little pieces coming out because you're going to choose 2 factors. Angelina, 3 is a prime number, so I'm going to circle it. What about the other number? Nolan, is that a prime number?
Mm-hmm.
It is. So I'm going to circle the 2 as well. It is an even number that is prime, you're right. Not a lot are probably not many at all. Actually, you're right. Because every number that's bigger than 2 can be divided by 2. You're right. So now, here's how we would list that. The prime factors of 30, and I'm going to put them in order because it makes it easier for things that we're going to do later on, okay? So I'm going to put them in order. 2 times 3 times 5. Do you see how I did not use this number right here?
Yes.
because that is not a prime number. In place of the 6, I put 2 times 3 because that's the prime form of that number 6. So my answer for this question would be 2 times 3 times 5. That's the prime factorization of 30. Now you can check your answer by going through and multiplying those numbers together. 2 times 3 is 6. 6 times 5 is 30. What if you used different factors? What if I chose 10 and 3? 10 and 3. So what if I use 10 and 3? Because I told you that there's more than one way to start this, right? So are either of those numbers prime? Yes, are either of those prime? Which one? 3. 3 is a prime number, so I'm going to circle it. Now I'm going to continue on here with the 10. What are 2 factors of 10? Hamza? 5 times 2. Are either of those numbers prime? What? Both. Both of those numbers are prime. So didn't I end up with the same numbers circled? 2, 3, and 5? But I started with a different set of numbers. But it's okay, because no matter what sets you start with, you're still going to get the same ending answer. So notice that I'm X'd out the 10 because you don't want to put the 10 there. And the way that you can double check your work is at the end, you can multiply it together and make sure that it equals that. So just as we did this already, 2 times 3 is 6, 6 times 5 is 30. So if you accidentally wrote the 10 here, you would get 300 if you multiplied it all out. And you know that that's not the number you're going for. So the only numbers that you should be listing today are going to be the prime numbers. That's it. It's only prime numbers. Yes, Nolan?
Are there any factor trees that are really, really big?
Yes. Once we get into big numbers, like numbers into 100 or bigger numbers like that, your factor trees can keep going and going. I'm not sure about today's lesson. We may not have that many that big. What?
24.
Because you have a lot of, you keep breaking down the numbers, right? You're right. So sometimes you can have more than one branch on your tree too. So what if I started this? I'm just going to show you one last one here. What if I started with 15 times 2? Because that's yet another way to get 30. 2 is a prime number, so I circle it. Then when I break down 15, that breaks down into 3 and 5. 3 and 5 are both prime numbers. So did you notice that I still got the same thing? 2, 3, and 5. So one person, like I could start with 6 times 5. Malachi could start with 10 times 3, and Ashley could start with 15 times 2, and we all get the same answer at the end. So as long as it's actually factors of that number and you didn't have your factors wrong, then you're going to get the same answer. It doesn't matter which ones you start with. Because some numbers, the big ones especially, have lots of different factors. Now, since Malachias brought up 24, let's use 24 as our next example. But I want you to try this one, okay? So I'm going to start it for you like this. In your notes, I want you to take a second to see if you can figure out what that factor tree would look like. And I want you to get down to the prime factors. So I chose 6 and 4. As I said, you could have chose 8 and 3. You could have chose 12 and 2. Whatever you chose, your tree itself is going to look a little bit different than mine if you didn't choose 6 and 4. But at the very end, you're going to have the same numbers as me. Okay? So if I chose 6 times 4, then I have to break down each of those numbers separately. So the 6 would be 2 times 3. And both of those are prime numbers. You'll start after a while to just kind of memorize the prime numbers, at least the small ones, like 2, 3, 5, 7, 11. We can make a little list if you want to in your notebook of like up to 20, the prime factors up to 20 if you wanted to. That way it can kind of help you remember. And then once you get started doing these after a while, you just will know automatically. Factors of 4 are just 2 times 2, and 2 is prime. So now when you list out the prime factors of 24, you get 2, 3 times 3. So 2 times 2 times 2 times 3. When I multiply that out, 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. See? So that's how you can check. So if we're missing a 2 or something, then you would know at this point because it wouldn't equal the same thing. Okay, did you guys all get that one? Let me give you one more just as a check. Try 20. Okay, let's see. What are two factors of 20? What did you get? 5 and 4. Anybody else use 5 and 4? Okay, anybody get something else? What did you get, Amelia? 10 and 2. Anybody else use 10 and 2? Yes? I think that's all the factors of 20 besides 20 and 1. So let's use 5 and 4 because that was the first one. Actually, we can, and then we'll do 10 and 2 over here. So if I used 5 and 4, 5 is a prime number. Bless you. Then I had to continue with the 4. So we're finding the factorization of 4, which is 2 times 2. Circled both of those. And then we do not need that number, right? Because that is not a prime number. That was a composite number that helped us get to the prime answer. But it wasn't part of our, it's not going to be part of our answer. So far I have prime factorization of 20 is 2 times 5. That's what I got on my first example. So if I went through multiplying it, I would get 2 times 2 is 4. 4 times 5 is 20.
Okay.
Now this one, if I use 10 and 2, like Amelia did, and Jalen I think used 10 times 2, then if I circle the 2 here, because that number's prime, and then I break the 10 down into 5 and 2, which both are prime, I still got 2 times 2 times 5. So when you get to your work today, you do not have to do both. You don't have to do both. You just have to do one. So you could either pick 10 times 2 or you could pick 5 times 4 if this were the question. Okay, you don't have to do both. So as I told you, we're gonna blend this lesson, we're gonna spread it into 2 days. So today we're gonna work on some of it and then tomorrow we're gonna work on the rest. So I'm gonna give you certain problems to do today, certain problems to do tomorrow. All right? We are gonna do all of the examples though right now. So look over into your book. Keep your notes, keep your whiteboard, look into your book. I'm gonna make this a little bit bigger so you can see it. Let me look. Says, Mr. Dempsey surveyed his class and found his students have a total of 36 pets. Write the prime factorization of 36. So we have 36 up at the top, and you can see that they've given you 2 factor trees here, and we're going to fill both of them in. So they've given you some of the numbers, and you're going to write the other numbers in. So we have 2 times something equals 36. Anybody know what that's going to be? What equals 36? 2 times something. That's a hard one. 2 times 12 is only 24. Aiden, do you think you know? 18. 2 times 18. That was a hard one. So what we've done in our notes and what I want you to do is to actually circle that number 2 and not continue writing it. But do you see how they just kept dropping it down, dropping it down? That just kind of makes it confusing. So you can cross that out. Now we have to break down 18. How would we break down 18? Amelia, how? What? 9 times 2? 9 times 2. 9 plus 9 you meant. So 9 times 2. So we need to write it in like this though. 2 times 9. And then I'm going to circle that 2. I really don't like when they give us all the boxes because it makes it really hard because we have to make sure we write the correct number in the box. If you wanted to write 6 times 3, could you write 6 times 3 right there? Yes, I like the thumbs up. That would give you another way to get 18, right? So we just chose 9 times 2, which is another way you can get 18. So now we got to break down the 9. 3 times 3, and both of those numbers are prime. So I'll give you a chance to catch up and give Aiden a chance to sharpen his pencil. Thank you for waiting until I was done. Okay, what if we use 3 as our first factor, like in this factor tree over here? What would the other factor need to be if one of them was 3? Nolan?
The other one would have to be 12.
The other one would have to be 12.
3 times 12 is 36.
Right. Now we're going to separate, we're going to break 12 down into 2 factors. So what might we choose? Anthony?
No, I have another question.
Okay.
What are the prime numbers?
They are any number that only has 1 times itself. So how about when we're done with this example, we'll make a short list really quick if you want to copy it down into your notes of numbers that are considered prime, okay?
Yes.
Okay, Tristan.
6 times 2.
6 times 2. Okay, I'll send him, thank you. Now what, how are we gonna break down 6? Angelina, how would we break down 6?
3 and 2.
3 and 2. And if I circle both of those, and then I look to see what I have 2 2s and 2 3s. And when you multiply that all together, you get 36. Thank you.
Give this to Samir.
Okay, thank you. Let's do example number 2.
Yay!
Find the prime factorization of 24. We did this one in our notes. So I would choose, let's choose 3 times 8. I'm going to cross these out and I'm going to circle that 3. Remember, as Nolan said, if you choose to continue pulling the number down, if that looks good to you and that works for you, definitely use that option. It's up to you. For the number 8, then I'm going to use 2 times 4. Circle that 2. Then I have to continue to break down 4, which would be 2 times 2. And then my prime factorization is 3 2s and a 3. And when I multiply that together, 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So this part here is really important to check your answer. When you get those numbers at the bottom that are prime, it's really important to check your answer. If you want to look over into your notes, let's list the prime factors up to 20. Ready?
Yep.
If you have your notes, open them up because I'm going to give you some prime factors up to 20. If you're comfortable with prime numbers and you don't want to write them, then you don't have to. This is like, it'll be kind of like a little cheat sheet for you to be able to go back and look. Here we go. Prime numbers. Only up till 20. If you want to, you can. If you don't want to, you don't have to. If you already know them, you don't need to write it. Here we go. 2, 3, 5, 7. Do you see how I'm skipping some numbers? The numbers that I'm skipping are numbers that have more factors than just 1 in itself, like 4 and 6. I'm also going to skip 8. I'm also going to skip 9. I'm also going to skip 10, because all those numbers have factors more than just 1 times itself. Then 11's a prime number. 12 has more factors than just 2. So then we go on to 13. 14 has more factors. So does 15. So does 16. Remember, because any number that ends in an even number, like 14, ends in a 4, and 4 is an even number, then that means it can be divided by 2, which obviously makes it more of a composite number than a prime number. So then we have 17 and then 19. Those are primes just up to number 20. That's not all of the prime numbers in the world. It's just the prime numbers up through 20, which we aren't using super big numbers. So you probably aren't going to get numbers that are much bigger than that you're going to need to worry about.
Thank you.
Okay? You are welcome. Now you can start on the guided practice with your group. When you and your group have finished in about 3 minutes, then we move on to independent practice, and I'll put your timer up.